Alright, moving on to our second lesson here. So we're going to talk about least squares regression. So in the last example, the model equation was given to us. They told us that y equals whatever they wanted for our equation. In the last one here, y equals 2.78t. They gave this to us. In example 2, we're going to need to try to come up with it for ourselves using a method called least squares regression. And all this means is we're going to take our line here and we're going to say what's the difference between the actual value 0.4 and our guessed value 0.5. The difference there would be 0.1. The difference here would be 0. The difference here would be 0.1. The difference here would be 0.1. We're going to take all of those numbers and square them. That's the least squares part. And we're going to find the line that has the smallest amount of squares. If that's confusing for you, don't worry about it too much. The biggest thing for right now is can we use it, not do we understand where it's coming from. That will come later. We will have to know this eventually. But for right now, let's just make sure we understand how to use it. And so how to use it, here we go for our example. Here's our data and here's our values. Notice they don't give us an equation. We need to come up with that. So let me flip back over to the calculator. I'm going to go back into my list and I'm going to clear this out and rewrite it. We've got the numbers. We're going to call this 0 and this 7. And I'll go over to L2 and clear it out. And let me type in our values here. See if I can see them both at once. Nope, not quite. And so I'll have to look in the book. 1 second. 7, 7.7, 8.5, 9.5, 10.6, 11.8, 12.9, and 13.8. And so let's go ahead in here. Now we do not have anything for our y yet. We don't have that. If we were to graph this, we would obviously want to change our window. 0 to 20, still fine. We could go 0 to 10 to make it a little tighter, but our y's are way off. Let's change this from 0 to, call it 20, stepping by 1. Alright, so we've got our data. We want to come up with a line that fits those. The way we're going to do that is back here in Stat. So go ahead and go to Stat, go over to Calc, and what we want to calculate is the linear regression. Linear regression, AX plus B. You should know this should look familiar. Slope intercept. Go ahead and hit Enter. Linear of AX plus B of L1, comma, L2, comma, Y. What did I type in wrong? Hold on 1 second, let me check the syntax here. Alright, sorry about that. The problem I was having, let me get the linear regression back up again, I can just hit the number 4, is it's supposed to be L1, say your first list, but we need to actually use the L1 right here instead of just typing L1. We need to use L2, and then we want to tell it what do we want by itself. What are we isolating? We're isolating the y variable, y1. So to get to that, we have to hit vars for variables, go to y variables, we're doing a function, and so there we go, we want y1. Linear regression ax plus b of L1, L2, y1, just hit enter, boom, there we go. Linear regression y equals 1.01x plus 6.7. If we were to graph this, let's copy this into our y equals, I'm just going to use the rounding that we had there, plus 6.7, and let's compare it to our plotted values, and we do have a nice model here that's coming very close to our values. Alright, there's one for you to try next, right here. See if you can use this and come up, oops, right here, there it is. See if you can come up with the scatter plot and then come up with a regression and compare the two model versus actual value. I'm going to pause the video while I type in all the information into the calculator so that we don't spend a lot of time watching me type numbers in. Alright, welcome back. Hopefully you have some data entered into your calculator, and we'll take a look at what you did. I chose to represent going back to the top of the list, 1920 as 20, 1952 as 52, so when we got down here to the 2000s, that became year 100 and year 104. It could have had something different depending on what you were doing. Alright, let's come up with the regression. Stat, calc, for linear regression of ax plus b, second L1, comma, second L2, comma, y1. And so again, to get to that, it's vars, y vars function, and y1. And so we've got linear regression. Let's hit enter, and here we go. 1.007. We'll call it 1.01 again. I'm just going to round. If we copied the whole thing off, it'd be more accurate. 130.8 is what we're looking at. Let's type this in. 1.01x plus 130.8 and go ahead and graph it, and let's check our window. 0 to 120, and we're going to be looking at values anywhere from 100 to 300. Let's go with. And there we have it. So a pretty good model. Not as tight as some of the other ones, but still reasonable for making assumptions in the future.